Okay, so this is another series of videos that are going to do a bit of an art class in R. And in this one, I'm going to introduce functional programming to you. So that's a very useful tool for programming in practice, and I use it both in my art and in my scientific work. So let's get started. All of this is available, like, if you want to see the code in its final state, it's up here at this GitHub repository for AshTree. Where we were at the end of the last art class that I did was creating the scroll system that created these pretty pictures, which you really liked, but I didn't write any new functions when I created scroll. If you want to play with it, by the way, I should just mention that it is also up on GitHub. But our goals here, going back on point, are to learn how to write our own R functions, create a new system with it, and we're also going to start using the functional programming toolkit that is made available with the Purrr package, which is part of Tidyverse. Our real motivation, though, is to create prettiness. So all of this is motivated by the Flame Tree package that I just made a little while ago just for fun, which draws these really nice looking trees. So it's things like that, and the Flame Tree package is up on GitHub, so you can play with that too if you really wanted to. What we're going to do in this class, though, is cover a simplified version of the system called AshTree called AshTree that generates these kinds of pictures. These little sorts of trees, which are still extremely pretty, but I don't have to do quite as much work. Okay, so why? Well, I hope the why for the art part is obvious, because it's pretty. The question is, why are we using functions? I didn't do that much last time, and so it's worth talking in some more detail about what the underlying logic for it actually is. I think of functions as serving 5 purposes. Firstly, you grab a chunk of your code that feels like it's all about the same thing. It's meaningful to group it together. Once it's been grouped together, that chunk of code can be reused. So you've got a chunk of code that is meaningful, and then we can give it a name. So if our function has a name, we have a named chunk of reusable, meaningful code. That sounds like a thing I want as a programmer. It also, as a convenient tool, it's a nice way of separating out stuff that your user, most likely you in the near future, actually needs to be able to use your code from all the stuff that your computer needs under the hood to do all of the dirty work. So your internal code can be kind of swept into a bunch of functions and hidden where the user doesn't have to look. Also, finally, the core building block for writing R packages, so you might as well learn something about how to write them. Okay, that's enough of the sales pitch for why do functions. How are we going to do this? Well, I'm just going to do this with a live coding exercise. We'll just start by writing one. The function that I want to write is a really simple one that is going to be it's going to get reused a lot in our package. All it's going to do, so notice that throughout the tree, you've got branches that split off at different angles. I think about angles in degrees that go around from 0, around a circle, to 360. When I'm doing my calculations under the hood, the computer prefers to think about these things in radians that go from 0 around to 2 pi. So it'd be really nice to have me as the human input degrees, because I can think in degrees. I can go, yeah, that's 0, that's 90, that's 180, and have it converted to an angle in radians that my computer can do all of their ugly trigonometry stuff with. So let's do that. Let's write ourselves a function that will do that. So I will just, to do that, what I'm going to do is go over here to a RStudio project that I just happen to have open. Remarkable. And when I do that, I'm going to go over here to write my function. I'll create a new R script. I will save it as ashtree.r. There's my file. And now what I want to do is have it do some calculations for me. So imagine let's just skip the program part, the function part for a second and think about what are the computations I need to do. Well, if my user gives me input called degree, degrees can go from 0 to 360. So let's divide it by 360. So that now we have a number that would go from 0 to 1. And then, to convert it to radians, what we would have to do is multiply that by 2 pi. So you've got something that goes from 0 all the way around to 2 pi. So we'll go that times 2 times pi. I will just, for those of you who don't know it, pi is an inbuilt constant in R, and it's about 3, which is close enough. So now we have the calculation that we need to return, that we want our function to perform. How do I get that as a function? Turns out it's surprisingly easy-ish. Okay, we'll call it, first we need to give our function a name. I'm going to call it radians, there we go. Radian, I don't know. What am I going to call it? Yeah, radians will do, that seems fine. Okay, we can always change it later if we feel like it. Okay, so functions in R, and I treat it the same as any other variable or object. So in the same way that I would create a new variable in R using the assignment operator, I create a new function in R using the assignment operator. So the function, well, keyword really, I need to use here to define a new function is function. That's at least relatively logical. And that now inside my round braces, what I want to do is say, what does my user need to input as the arguments? There's only one argument that we need because pi is a constant in R. Degree is the only input it needs. So we can go degree is the only argument. Then we should put all of this in a code block, kind of like we do for loops or conditionals. If you don't already know about loops and conditionals, I'll try to talk about them as we go, but really that's what the scroll art class was about. So I'm assuming a certain amount of knowledge about that kind of thing. Anyway, the code block here is just the chunk of code that's inside these squiggly brackets. So let's move that inside our squiggly brackets, which I remember how to do. No, I don't. Sorry. Okay, there we go. Okay, and we're done. This would actually be a perfectly working function. I'll just confirm that by saving it and Control-Shift-S to source, as I usually do. And now we'll go Control-L to clear my screen. Radians. So let's say take a 90-degree angle. So we'll take degree of 90-degree angle. What is that in radians? Okay, 1.57. 180 degrees is pi. Yep, that seems to work. Our function actually is capable of doing slightly more than that because we've written it in a way that all of these operations would work just fine if degree was a vector. So if I go degree equals c of 45, 180, so we're going to give it two angles as the input. It will spit out 2 angles as the output. So our code actually was automatically capable of handling vectors as well as single numbers, which is super useful. Now, the thing that I want to kind of highlight before ending this one is that we can give our function a little bit more internal structure. I mean, in truth, this one doesn't need any more structure. And so I'm going to delete it again in a moment. But what I'm actually going to highlight is what I could do is break this down into steps and go prop. So that's the proportion of distance around the circle is, we'll just grab that and chuck it up there. And then what we would do is take that proportion and convert it to radians. So prop times, like that. And then what I would do at the end is say the value that the user needs to return, or we need to return to the user, is rads. When you have, if you don't specify an explicit return value like that, R will just assume that whatever the last thing you did, that's the that becomes the return value. I usually like to make my functions a bit more explicit, so that I actually do have the return value stated explicitly, but that's sort of something that people have different opinions about that one. Okay, so that would be my radians function. I'll save this again and we'll source it again. Notice nothing runs. It doesn't compute anything other than defining the radians function when I source the script. If I call this function again, so if I just go radians, doesn't really matter, 435, it's going to complain. Why is it complaining? Because object prop not found. The reason is that there is a space here. Oh dear. Better fix that. Something worth noting. I sourced the script that had an error in it when it defined my function, but the error didn't actually get noticed until I tried to run it. This is a thing to keep in mind. You can write bad code, like I just did, inside a function, and it won't necessarily, I won't discover that there's something wrong with it until you try to run it. So, okay, let's go back now. We'll save this and we'll hope it works this time. So let's source our new thing, and I'll Control L to clear my screen. So now we'll type radians of, let's give it a real number, real sensible angle this time. It works as expected, but notice the value of prop and the value of rads do not appear anywhere over here in the environment pane. Everything that happens in this section inside the body of the function happens in its own space. It does not happen here in the global environment, right? That's your workspace. It happens in a different environment, somewhere else. So all of these things are kind of like temporary variables that R creates while it runs the function, and then once the function finishes, they just disappear again. The truth is slightly more complicated, but that's a pretty good first pass, and that's the way I used to think about functions all the time. So all this stuff is on the inside. Whatever this is gets returned to the user. So if I go R is gets radians 34, now you can see we've created a new variable in the workspace. And it's called R, it's not called rads. I could do something really similar here and go D is 34, right? And then go radians degree equals D. And internally, even though my function over here doesn't say D, it says degree, what it's done is use degree to refer to D. In other words, the argument is the function's internal label for whatever variables or objects or values you give it as input. And the same thing with the return value. This is rads is the internal name that the function uses to label it. What becomes the external value, whatever gets returned to the user, is whatever the user wants to call it. So over in my global workspace, I've just got R and D. Over here in my function, I've got rads and degree and so on. Okay, that's enough of that. We've got our first function. My 15 minutes of rambling are up, so I will stop this one here.